Hi guys, in this video we are going to discuss Ionic Equilibria. Now there is a mnemonic, interesting, Arlo-Lay. Alright, this belongs to Arhenius, Lowry and Lewis. Alright, now this is in sequence. Alright, so you know if this was first, then second and third. Let's try and understand one by one briskly. Okay, Arhenius. Arhenius was one who told that anything giving out H plus is an acid. So acid provides protons. HCl gives you H plus and Cl minus. Similarly, bases provides OH minus. BOH giving you hydroxide. Sodium hydroxide gives you OH minus. So it's a base. One which gives H plus proton is an acid. One which gives hydroxides is a base. No explanation was provided for sodium carbonate or ammonia. Why are these bases? No explanation provided. Again, nor any explanation for why BF3 or aluminum chloride behaved as an acid. This did not produce OH minus, neither did this give out H plus proton. Still, these are bases and these are acids. Further development would explain the properties. Alright, now let's get into Lowry. So Lowry, what did he talk about? He also talked about same acid and bases, but what he told is substance which donates H plus to another substance is an acid and the one which accepts is a base. Alright, just modification of this. Alright, so HCl, ammonia, HCl gave its proton to NH3 ammonia. It formed ammonium plus and HCl became Cl minus. Another concept that he introduced was of conjugate acid and conjugate base. Now ammonia is a base. Now it accepts proton from HCl and forms conjugate acid H plus, NH4 plus, NH4 plus acid. So it forms acid, but conjugate acid. Similarly, HCl, which was an acid, gave out its proton and formed Cl minus, a conjugate base. Alright, so he introduced term conjugate acid and conjugate base. Alright, fine. So this is what I explained already. So base which accepts proton, H plus from acid becomes conjugate acid and vice versa. So we are talking of base becomes conjugate acid, then acid becomes conjugate base. That's what I meant by vice versa. Alright. Another interesting aspect that he introduced was now H2O, water. Now see, if you check out water over here, this is its electronic structure. Alright, so oxygen has 1, 2, 3, 4 dotted, 6 dotted. All dotteds are electrons for O, oxygen. Alright, and cross is hydrogen. So water, when we talk about, is this, right? It shares one electron with hydrogen and complete its octet. But it has got two lone pair of electrons. So what happens? This H plus is running short of 2 electrons. So what it comes is it attaches there. It comes and attaches there, and now what happens is it forms H3O. But it also has this positive sign, so it is H3O plus. Alright, and this he called it as hydronium ion. Alright, so he called it as H plus. So now let's understand a reaction where H3O plus is formed. So HCl plus water. Alright, HCl reacts with water. It provides its proton to H2O, forms H3O plus, and HCl forms Cl minus. So HCl, which was an acid, formed a conjugate base introduced by Lowry. And another concept introduced is of hydronium. Proton gets attached to water, forms H3O plus. So this is yet another concept of hydronium ion introduced by Lowry. Okay, so these are the concepts introduced. Now let's understand what Lewis has to convey. Now it's about species running. Now Lewis told that when you talk about BF3 and aluminum chloride, these do not provide H+. In spite of that, we call it as an acid. Alright, same story with ammonia and water. Does not provide any OH, but we call these as bases. Why? Now the explanation goes this way. The species running short of electron, as per Lewis, H+, if you check out, H+ is running short of electron, and since it is running short of electron, so we call it as an acid as per Lewis. In case of Arhenius and Lowry Bronsted, it is H+1 which gives out H+, but Lewis conveyed that if it is running short of electron, whether it be H+ or any other molecule, if those molecules or atoms are running short of electron, then they are acids and known as Lewis acid. Now let's try and understand. Now when you check out boron, boron has got 3 electrons in its valence shell. Alright, these dotted ones are 3 electrons of boron. It shares with fluorine 1 electron. Fluorine is running short of 1 electron. It has got fluorine has 7 electrons in its valence shell. It needs 1 to complete its octet. So it shares with boron and completes its octet. Similarly here. So fluorine, F are satisfied with its octet, but BF3, if you check out, it has got only 6 electrons. Boron, if you check out, it has got only 6 electrons in its valence shells. So its octet is not complete. So it is running short of 2 electrons. Now since it's running short of 2 electrons, so it's an acid. Alright, it's not giving out H+. But since it is running short of 2 electrons, so it's an acid. Same story is also with aluminum chloride. When you check out, it's running short of electrons, so aluminum chloride also acts as an acid, not providing proton at all. Okay, alright, so that's what it is all about acid. Now let's check out for bases. Now in case of bases, what we find is, if we check out ammonia and water, nitrogen has 5 electrons in its valence shell. It needs 3 more electrons to complete its octet. So what it does, it shares it with 3 hydrogen. Alright, so forms ammonia, but it has got lone pair of electron, 1 lone pair of electron. This can be shared. So we can say that it has excess of electron pair. Now since it can share, so it acts as a base. Alright. Same story is with water also. Now in case of water, you know, O has got 6 electrons in its valence shell. It needs 2 electrons to complete its octet. So it does it with H, shares it, but then it has got 2 lone pair of electrons. So it becomes a base. So water also acts as a base. It is not giving out OH, neither is ammonia giving out OH minus, nor water is giving out OH minus. But still it acts as a base. Why? Because it has lone pairs of electron. This has got 1 lone pair of electron. This has 2 lone pairs of electron. So it is. So these both stuffs are bases, ammonia and water. Alright. So this is what it is. Species running short of electron. As per Lewis, H+. Also, if you take an example, is an acid. As it is running short of electron, it needs electrons. Alright. So we saw it over here. Then next one, species which can donate electrons are bases. That's what we saw over here. Alright. As per Lewis, OH minus has electrons to donate. Alright. Okay, now just let's check out this. Now we just combined this and this. Now ammonia, rich in electron, it has got a lone pair. So it gives it to boron. BF3 needs a pair of electron to complete its octet. So this becomes donor, and at the same time it's Lewis base, whereas this becomes an acceptor. At the same time it is Lewis acid. I hope the story of Arlo Lake is understood well. Alright, see you.